All right, we're going to try this again. Our last lesson that was recorded, lesson 152, I guess it would have been, the sound didn't work, so we're trying this again. Unfortunately, that means there's no students in here. So we start with a word problem. And so take just a moment or two to work the word problem. Pause the video if you need time to work it. If you worked it yesterday while the video was silent, then you can just continue rolling. All right, hopefully, as you looked at the first equation, you recognize that the difference between two numbers is 7, means that take one number minus another number is going to give you 7. Difference means subtract. What that also means, though, is for you to take x and subtract y and get a positive, means that x must be larger than y. So x is big, y is small, x is bigger by 7, in fact. Then it says the sum, so we're going to add some things, of twice the first and 4 times the second is 26. Now, you may notice as you write this, hey, I could take a 2 out of everything here. That's true, you could. You still couldn't cancel anything, though. And I'm looking at the y here. And again, if you take a 2 out of everything, that still would leave you with a 2y, and you still have to multiply the top by a 2. I just assume multiply the top by a 4 and get 4x negative 4y equals 28. That allows you to cancel the y's. Remember, you're adding. So don't subtract to get 2x. You're adding, should get 6x. And you're not subtracting, you're adding and should get 54. So that you end up with x is equal to 9. When I recorded it live with students, I did have a student subtract, get 2x equals 2, so x is 1. Well, that really causes a problem because 1 minus negative something, anyway, it didn't check out, obviously. Going back to the original x minus y equals 7, if you plug in the 9 here, you could move the 9 over as a negative and then change the signs to get y equals 2. Or you can just think this, 9 minus what equals 7? Obviously, 9 minus 2, so y equals 2, and my numbers are 9 and 2. Hopefully you got that for the word problem. Let's go ahead and go to a new section in your notes. Let's talk about, to really review, something we looked at earlier in the school year. I think it was back in October, perhaps. We began looking at this concept of raising a monomial to a power. Raising a monomial to a power, and I want to address that with you now. So if we have a monomial and we want to raise it to some power, you may recall that there are 3 steps to raising a monomial to a power. The 3 steps were sign, number, letters. Or usually I say it in the singular sense, sign, number, letter. A couple things about the signs when raising monomials to power. First of all, remember that a positive to any power will remain positive. Doesn't really matter. Multiply as many positives as you want, you're always going to get a positive. Negatives are where things start to get dicey. But you may recall that if a power simply indicates how many times something is used as a factor. So an even power would literally mean an even number of negatives. And you know that an even number of negatives gives a positive, so it makes sense then that a negative to an even power would produce a positive. So really when raising to a power, the only time you'd end up with a negative is if you had a negative raised to an odd power. Because negative to an odd power means I have a negative number of negatives, which an odd number of negatives rather, which gives me a negative. So sign is something we have to consider as we raise a monomial to a power. We should also consider the number. Remember, for the number, it should be used as a factor the exponent number of times. Now that means we're going to not multiply, for instance, if we had, let me throw this out there, negative 10x squared y, if I cube it. It doesn't mean I'm going to multiply 3 times. It's not 10 times 10 times 10 times 10, but rather there are 3 tens being used as factors. 10 times 10 times 10. 3 tens, 2 multiplications in there to get 1,000. So the number used as a factor, the exponent number of times. And then as far as the letter, and you'll want to put a star next to this and memorize it. In class, when we had students in here, we would drill over and over again this statement: to raise a power to a power. To raise a power to a power multiply the exponents. To raise a power to a power, multiply the exponents. The thought being, if you had x cubed to the fourth power, well, that means x cubed times x cubed times x cubed times x cubed. And remember, when you multiply like bases, you would add the exponents. This is literally 3x's, 3 more x's, 3 more x's, 3 more x's. That's 12x's, right? Well, it's faster just to multiply the exponents and get x to the 12th that way. So to raise a power to a power, multiply the exponents. So in this example here, negative to an odd power, of course, is going to be negative. 10 cubed will be 1,000. 10 times 10, 100 times 10 again would be 1,000. And here I'm raising a power to a power. I'm going to multiply the exponents. 2 times 3 gives me a 6, x to the 6th. Here we've got the understood 1. 1 times 3 is 3, so y cubed. A few more examples for you to work along with me there at your house, or if this is being used as a substitute for myself and my sickness, to do in the classroom. But some examples that we can work here. 4 to the 5th. Take a moment. 4 times 4 times 4 times 4 times 4. Pause the video if you need more time. Hopefully you got 1,024. A squared to the 5th power. Well, when you raise a power to a power, what do you do with the exponents, Gavin? I couldn't hear you. You got to speak louder. Okay, I'm just kidding. Multiply the exponents, a to the 10. And of course, here, b to the 4th to the 5th would give us, I trust you are correct in saying b to the 20th. How about this next one? Write this down and work it with me. Negative 2mn squared raised to the 4th power. Thinking through sign, number, letter, what's the sign going to be? Positive. And why is that? Because you have a negative to an even power. All right, how about the number? Good, 16, not 8. It's not 2 times 4. It's 2 times 2 times 2 times 2 to get a total of 16 as you multiply. And then for the letters, we multiply the exponents to get m to the 4th, n to the 8th. Here, it's 2 times 4. Here, it's 2 times 2 times 2 times 2. Okay, so just keep those straight there, exponents versus the other. And you will see from time to time annoying things like literal exponents. Here we have an a squared b to the xc cubed all raised to the nth power. Well, as far as the sign, it's an understood positive, and positive to any power is still positive, so of course positive. Number is a 1. 1 to any power is 1, so of course it's 1. We can kind of skip sign and number if you don't see them. So we're really only going to take care of the letters, but remember, when you raise a power to a power, multiply the exponents. And so here, when I multiply the exponents, it's going to give me a to the 2n. How about the b? It'll be b to the, keep them alphabetical, nx, and then c to the, and it's not pretty, but there it is. A to the 2n, b to the nx, c to the 3n is our correct answer. In the description of the video is a handout that you will complete, just the top section of the handout. I want you to do 1 through 11, the odd. So on the handout that's in the description of the video, pause if you need time to print it. I want you to do just the top portion of the handout, 1 through 11, the odd. Pause the video while you work, and when you resume, I'll give you the correct answers. All right, let's go and take a look at the answers to the top section, 1 through 11. Number 1 should be a squared, b to the 4th, c to the 6th. You are multiplying the exponents because you're raising powers to powers. Number 3 should give you 8, not 6. 2 times 2 times 2 is 8. A to the 6th, c cubed. 8, a to the 6th, c cubed. Number 5 should be negative raised to odd powers, negative, 64, 4 times 4 times 4, c to the 6th, y to the 15th. Multiply the exponents. Again, negative 64, c to the 6th, y to the 15th. Number 7 is really annoying because all the exponents right now are 1s, and you multiply those exponents times the m, which gives you m. So a to the m, b to the m, c to the m, x to the m. That's your answer. It's ugly, but it's right. Number 9, negative 1. Remember, negative to an odd power is negative, and 1 to any power is 1, so negative 1. And number 11, well, again, can't really do much here, so 3 to the n, b to the n, c to the n. Hopefully you got them all correct. If you didn't get that and you're not sure why you missed it, reach out to me via email and I will certainly take time to help you there. Now, if you look at the bottom of the handout, you notice, oh, fractions, this is awful. Well, it's actually not so bad. Because if you have a fraction, for instance, let's just say you've got a negative 5a cubed x squared all over 7b squared c, and I were to square it. Keep in mind that a fraction can have up to 3 signs in it, 3 negative signs in it. The sign of the fraction, the sign of the numerator, the sign of the denominator. Well, if 2 of them are negative, they would cancel. Any 2 of them would cancel. If all 3 are negative, these 2 would cancel, leaving you only this one. And if there were only 1 negative, it would always be slid out front. So if there is a negative, it belongs in the front anyway. So before you even deal with the fraction, deal with the sign. It's a negative to an even power, gives us a positive. And then from there, we square the top. 5 squared means 5 times 5. A cubed squared, and x squared squared. In the denominator now, we take care of that. So we take care of the top, then we take care of the bottom. It's like 2 problems for the price of 1, and you want a refund. All right, so 7 squared would be, there we go, the b squared squared, and of course c to the first squared. Let's suppose this had been cubed. Well, now negative to an odd power gives us a, and now we take care of the fraction. Go ahead and cube the top, pause the video. All right, trust that didn't take you real long to get 125 a to the 9th x to the 6th. Pause the video while you cube the denominator. All right, trust you got 343 b to the 6th c cubed. And this would be your answer. So again, in working with a fraction, take care of the top, take care of the bottom. If there's a negative, it'll be up front anyway, or should be up front anyway. Take care of the sign before you deal with the rest of the fraction. Go ahead and do the bottom portion of the handout now. Numbers 1 through 9, the odd. The bottom portion of the handout now, numbers 1 through 9, the odd. Pause the video while you work. All right, let's go and take a look at the answers to numbers 1 through 9, the odd. Number 1 should be 1 over 16b squared. Number 3 should be 9x to the 4th over 100y to the 6th. Number 5 should be a positive 16 over 81x to the 4th. Number 7 should be positive 64a to the 6th over b to the 6th. And number 9 should be a to the 2n, b to the 3n over x to the n, y to the 4n. Trust you got all of those correct. If not, reach out to me and get some help as needed. I did want to mention, and I mentioned this live to my class yesterday, that you don't have to worry about reducing a fraction when you raise it to a power if it's already reduced before you start. So if reducing can happen, do it before you raise to the power. It'll make your life a whole lot easier. But if there's nothing that reduces at the beginning, raising to a power will never enable you to reduce later. So just one less thing to worry about. The final thing we want to cover here is some powers that you're going to need to memorize. You should already know, just from your elementary, junior high days, 1 through 12 squared. You should know, for instance, that 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. Of course, the rest of them. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. All of those we should already know. But we're going to have to memorize some more of these because we're going to see a lot of these, and you need to have a bigger tool, a bigger arsenal of knowledge than you have currently. So we're going to memorize up to 20 squared. So if you will, go ahead and write these squares down in your notes, and we're going to commit these to memory. You will be quizzed on these in lesson 155, so make sure you have these memorized. But write this down. 13 squared is 169. 14 squared is 196. Now you'll notice these are very similar. The digits just are reversed. The bigger one is with the bigger number, the smaller one with the smaller number. So usually students memorize these together. 15 squared is 225. By the way, you know if it ends in 3, 3 squared is 9, 4 squared is 16, 5 squared is 25. So you know the ending digit of each of these. 16 squared then, well, if 6 squared is 36, so therefore this has to end in a 6. It's going to be in the 200s, and I don't know if this is a good way to help you necessarily remember it, but 256. Maybe you think there's the 2, there's the 6, and the difference is the 5. It's kind of a stupid way to remember it. It's not why it works, certainly, but maybe it'll help you to remember 256. 17 squared is 289. Now, you already know that 9 squared is 49, so you know you're going to end in 9. Here's how I remember it. 9 plus 8 equals 17. It's the only set of 2 single digits that you could add to get a 17. That's how I remember 289. 18 squared is 324. Now, for years I struggled with this one until a student pointed out that 32 divided by 8 equals 4. And 3 times 8 equals 24. So the 8 is kind of in there pretty hard. Plus, you know 8 squared is 64, so you know it has to end in a 4 already. Then remember, times 8 would be 32. If that helps you remember it, I don't know. 19 squared, 361. Again, you know 9 squared is 81, so you know it has to end in a 1. But here's a 9, and there's a 1. Here's a 1, and there's a 9. I don't know if that'll help you. That's how I actually remember this, is the 1, 9, 9, 1. And then 20 squared. No students struggle with this one. 400. Square the 2 to get 4, and square the 0 to get 2 of them. And there's that. So these are all ones you're going to be memorizing. Practice them, drill them as needed to learn them. We'll do some drill in class in future lessons. You're also going to memorize some cubes. Now, of course, you know that 1 cubed is 1. 1 to any power is 1, so I'm not worried about that. But let's start with 2 cubed. Really, you can do this in your head very quickly. 2 times 2 times 2 is 8. 3 cubed is also one that, frankly, you could do in your head in a pinch very quickly. 3 times 3 times 3. 4 cubed starts being harder to do in your head, so you really have to memorize this one. It is 64. So I'm going to draw a line here, because really these you can kind of do even without memorizing. You do them so fast. 4 cubed is 64. 5 cubed, 125. And 6 cubed, 216. Now notice, 4, 5, 6. That's not true of all cubes, obviously. But it is true of these 3. Also, there's a 12, there's a 21. They both have the 3 at the beginning, it's just one's reversed. Why? Because this is bigger. Of course it's going to be a 2, 1. This is only going to be the 1, 2. Also, students sometimes get these confused. But remember, 15 is so much bigger that it's going to be so much bigger when you square versus when you cube. So the smaller number, 125 versus 225, goes with the cubed 5. The bigger number goes with the squared 15, if that helps. 7 cubed is 343. Here I notice there's a 7 and a 7, no matter which way you start, because it's a symmetric number. 8 cubed, I have had a student point out you can add all 3 values together to get 8. The way I remember this is kind of a nerdy way, but computers, 512 gigabytes is one of the larger solid-state drives at the moment. I know terabyte solid-state drives are out there, but they're very, very expensive. But 512 gigabyte solid-state drives are not. So 512 is a computery number. In fact, when I was I guess junior, senior year of high school, this was, back in the Stone Age, but flash drives first came out. And they had 128, 256, and 512 megabyte flash drives. 512 was the biggest they made. They didn't make gigabyte flash drives yet. There were 512 meg was the big one. And if you had a 512 meg, it cost you $40, $50 for that flash drive. Well, that's how I remember 512. It's just a computery number. 9 cubed, 729. There's a 9, there's a 9. So these are kind of a sum of digits, kind of adding digits in different unique ways that help me remember these. Last of all, 10 cubed, nobody struggles to remember. You cube the 1, you get 1. You cube the 0, you get 3 zeros. And there we go, 1,000. Find ways to remember them. I have my own goofy ways. Maybe they help you. Maybe they don't. Maybe you have to come up with your own goofy ways to remember it, but do what you have to do to memorize these. Finally, we've got some powers of 2. 2 is such a nice, easy little number. 1 to any power is 1, but 2 to any power is a 2, right? It's got lots of different things. So we're going to memorize our powers of 2, starting with 2 to the 0, which is, of course, You didn't say 0, did you? 1. Anything to the 0 power equals 1. Hopefully you said, I'm going to give you the benefit of the doubt, assuming you did not say 0. 2 to the first, of course, is, yeah, because anything 2 to the first power is itself. Of course, we know 2 squared is 4. We already have 2 cubed up here. 2 cubed is 8. So really the only powers that you should have to spend time memorizing are 2 to the 4th, 2 to the 5th, and 2 to the 6th. Now, if these are in a list, it's really easy to remember them. You just double the 8 to get 16, double the 16 to get 32, and double the 32 to get 64. But they're not going to be in a list when I quiz you on them. So something I remember here, if you were to switch the base and exponent, 4 squared is 16. Maybe that helps you remember 2 to the 4th. Now, obviously that breaks down here because 5 squared is 25. But the sum of the digits is 5. Maybe that helps. And then for the 64, it leads with a 6. I don't know. Come up with ways to memorize these as needed. Make sure these are all copied down. Rewind the video if you need to make sure you've got these copied down, because for homework this evening, you're going to make flashcards. Maybe on 3x5 cards, maybe 3x5 cards cut in half because you're cheap, like me, and you don't want to waste a whole 3x5 card on one little math fact. But make flashcards and begin drilling yourself on these. You will need to have these memorized very well for lesson 155's quiz. I'll give you more information about that in your next lesson. All right, well, I apologize for no students in here. I really have no clue what happened to the audio in the last attempt at recording this lesson, but hopefully this was beneficial to you. Let me know if you have any other questions. Don't hesitate to let me know if you have issues, questions, or anything else, need help in any way. All right, have a great day, Gavin.